Oh, no, that's perfect. No, it kind of sucks. Let's see. Okay, let me show you. Let's do all the hard stuff now. We'll do the fun stuff in the second half. So here's another one that would take you 2 hours and emails and going to help and all that. And I think I'll not do it in the mathematical detail I was going to do it in, but I'll tell you how to do this because you need to know how to do it. Here is another thing, angles, right? So here, the whole time we were doing the theta naught, this initial angle, but the angle changes as something flies, right? So let's see, let's say how to find the angle of a path. Very important. So I had a numerical version. What I'll do is I'll give you the numbers, and you can later see if you can get the numbers to work out. Something flies at 5 meters per second. All right? At 45 degrees. So the trajectory does something like this. Like that. The time, I'll just tell you, you could plug and chug and get the time, is 0.72 seconds. It's only in the air for just a second. Those bullets were in the air a long time because the air was slowing them down. Most of these aren't that long. Yeah. So then the question is, what is the angle at, I think I did t, I just drew a b, what was I thinking? At t equals 0.45 seconds. So t equals 0.72. What is this t? Somebody shout out what the time is when that happens. 0.36, good. You either don't know or you can't shout. Okay. Or both. Okay, yes, you're right. So since this is symmetric, half the time goes up, half the time goes down. This is 0.36 seconds. Right? This was 0.72 seconds. Right? So in this problem I said, find the angle at 0.45. I was just trying to find a place around here. What is the angle of the trajectory at 0.45 seconds? That's the question. Okay, so here's what you do. We won't do the math, but I'll tell you what you do. You need an angle, probably related to a vector, right? Let's identify some vectors. Is the angle of the trajectory this? No, that's not what we mean. You could argue that is the angle of the trajectory because the particle's on that trajectory and that's the angle of r. So you could say this is what you want. Well, you can say that if you want, but I wrote the problem and we wrote the answer. So that's not what we want. When we say the angle of a trajectory, we mean tangent to the trajectory. Okay? So which vector is going to give you that? V. All right? So how to find the angle of a path is it's the angle of V at t equals 0.45 seconds. So you got to do in this problem is figure out what are the components of V there. It's actually an uneven trajectory problem, really. You can use the even formulas to get the top, and then you got to figure out what it's doing at this point. Although you really don't have to always break it into two parts. So you'll find out how you could also do it with just one set of equations as we do more as we go forward. But ultimately, how do you get an angle is you got to realize, okay, this V has two components. It has a component this way. It has a component this way. Right? This is the x component that never changed, and this is the y component that's going positive and then negative. So if your V looks like this, and you have Vx, and you have Vy, that's the angle right there, and it is the tangent of that angle is Vy over Vx, if you're following the standard definition. Okay? So when we solve this problem, and I'll give you the answer, what we would get is a negative number here, right? Because Vy is down. So that's a negative component of the velocity vector. We get a positive number here because Vx is to the right. So we get the tangent of a negative number. And the inverse tangent of a negative number is a negative angle. So the answer is minus 13.9 degrees. Okay. And that's that's right. It's negative 13.9 degrees. So if you want to go through the kinematics later and see if you can solve that one, it'd be a good practice.